All right, we're almost there. To find the instantaneous velocity at time equals t equals a seconds, we're going to just take the limit as the amount of the elapsed time goes to zero in the average velocity. And that makes sense. If we want the velocity at a precise moment of time, then we have to have the difference between the initial velocity and the final velocity just disappear, go to zero. Well, h is what we call the difference between these two time values. So we'll take the limit of the expression that we developed in the last example for the average velocity, and we'll let the difference between the time values, h, approach zero, and that answer will be our velocity at the instant, time t equals a. Here's our example. Estimate the instant velocity at time t equals 1. We're using the same function that we used last time. So the solution to this problem is to just use the formula for the velocity that we developed, but let h go to 0. So now this velocity, we're going to kind of call it v t equal a. In other words, it's the exact velocity instantaneously when t is equal to a. It's a limit as h approaches 0 of f of a plus h minus f of a over h in general. For this particular problem, though, we're going to customize it using the function f of t equals 10t minus 1.86t squared, and we're going to use the value, the initial time, the time that we're looking for this instantaneous velocity, a equals 1. So the formula that we used with those two factors, f of t and a equals 1, turned out to be the 6.28 minus 1.86h. So our instantaneous velocity at t equal 1 is equal to the limit as h equals 0 of 6.28 minus 1.86h. Now the 6.28 minus 1.86h is just a polynomial in h, which means we can do a direct substitution for the limit. Let h equal 0, simplify, and we get 6.28 meters per second squared. So what that says is that at the exact moment t equals 1 second, this object is moving at a velocity of 6.28.